Hello, welcome back to my video lecture on Maxima programming. Today we shall discuss about the numerical integration using Weddles Rule. In earlier videos we have already seen how to write the Maxima program to evaluate a definite integral using trapezoidal rule, Simpson's one-third rule as well Simpson's third rule. Today we shall see how to integrate the definite integral using Weddell's rule. The Weddell's general formula is like this. If we want to integrate uh, from x0 to xn is nothing but x0 plus nh of any function f of x dx, the solution will be in this format: 3h by 10. H is the distance or a width of each interval. What is the width of each interval? All h is similar to all the intervals. Okay, then function values, initial function value, and this is the final function value. Suppose I'm integrating from 0 to 6, then there are 6 intervals. So then what I have, 0, y0, y1, y2, y3, y4, y6 will be there, right? If we are integrating with 10, there will be up to y10 will be there. y0, y1, y2, that all are called as function values at particular values of x. So first 3h by 10 and y0 to final value, y0 initial value of the function and final value of the function, and here 5 times y1, y4. See, y2, y3 are separately taken here. y3 with respect with 6, y3, y6 third multiple of function values, and 6 multiple of function values, and even multiple of the function values which are excluded here. So this total formula is called as Weddell's rule to evaluate the function values from x0 to xn. Any function we can take. This is one of the best method as compared to the trapezoidal rule, Simpson's one-third rule, and third rule. Weddell's rule gives an good accuracy in the result. Good accuracy. They are the improved result of the definite integral. So trapezoidal rule, as compared to trapezoidal rule, Simpson's one-third rule is giving good result. As compared to Simpson's one-third rule, third rule will give the better solution. And comparing to all three, the Simpson's trapezoidal rule, the Weddell's rule gives a good result for the evaluation of the definite integral or numerical integration of any function from x0 to xn. The interval may be anything. Let us see how to write this program for one example. Okay, this is the Maxima window. So we can write hash star lab 5 numerical integration by Weddell's rule. So this star again hash will be, slash will be there. So this line will not executed because we have written a comment line. Okay, now as usual, this kill all s is what? It will be used to erase all the data which has been done earlier. So suppose we are writing this number of programs in a single window, then kill all is used to erase all the earlier data of the programs. Okay, so we have to write kill all this $. fp print press. fp print press, file print press means it will give the how many decimal accuracy is required we have to give. So I have written here 5. We can take any decimal accuracy. So it will give up to 5 decimal places accurate result will be given. So we have to integrate this function f of x equals to 1 by 1 plus x square from x0 is 0 and xn is 6. So integration of 0 to 6, 1 divided by 1 plus x square is the function is given to us to integrate. Okay, h I have taken as 1. Then what is the number of intervals? So xn minus x0 divided by h will give the number of intervals. Just I will execute this by pressing shift enter. So it will give the number of intervals. How many intervals are there? 0 to 6. So x0 to x1, x1 to x2, x2 to x3, like that up to x6 the intervals are there. Each interval width will be 1. So now we have to find what is the function value 1 by 1 plus x square at x0, at x1, at x2, all the values we have to calculate. So that is I have declared here x0 is 0, and from x0 to x1 what is the width? 1. So x1 is 1, again x1 to x2 is 2, 1. So 1 plus 1, 2. x2 to x3, 3. x2 to 3, x4, 4. x4 to x5, 5. So there is a difference of only 1 from each interval. So up to x6 I have taken because the intervals are 6 we can make with h equals to 1. Now I will calculate the function value at x0. This is the function value at x0. Float is given to calculate the function value in the decimal places, right? Otherwise it will give the fraction values, right? So we have to give just I will remove this, just I will show you how to how it will give the value. So this is the y0 is the function value at x0, y1 is the function value at x1, y2 is the function value at x2. Similarly up to y6, 6 the intervals are there. Up to y6 we have to calculate the function values of the given function at these values. So after writing this all, just shift enter, it will give the function value with 5 decimals. Shift enter. See here how this is the y0 value, this is y1, y2, y3, y4, y5, y6. So 6 values are given to us, right? Now we will substitute these 6 values in the Weddles formula. What is Weddles formula? 3h by 10 initial value of the function, final value of the function. Up to y6 is there, y0 is the initial value and y6 is the final value, right? Plus 5 times y1, y5, because y2, y3 are taken in other brackets, therefore we have to take y1, y5, again y7, y10 will be there, but here what happens, only 2 values are there before y6, okay? So again the even values of functions y2, y4, y6 is already taken here, so we cannot take this here again once again. Next 6 times y3 is there, 6 times y3, because 2 times y3, y6, y6, y12 will be another formula. 2 times, just I will show that 2 times y6, y12 is there, but already y6 is taken here and y12 is not there, therefore this has been not written. Only we have to write this 6 times y3. y6 is again written here, therefore only the third value is what? 6y3. So 3h by 8 as it is, y0, y6, 5, y1, y4, up to y6, y1, y4 only 2 values come, and again here in the summation of even values y2, y4 will be there, and here y6 already it will come here, therefore again we should not take this, complete this bracket is omitted. Then the 6 times y3 we have to write, but y6 is already written here, therefore we should not take this, just we have to write like this. So the 6 y3 only taken, y6 is again came here, so not we should not take, as it becomes a repetition, otherwise in the formula will be wrong. So after writing this I can print the solution. How I can print the solution? So inverted comma I have to write, inverted comma I have to write, what I have to write? The value of given integral by Weddles rule is, I have calculated by what? Sol, S-O-L, solution. So that I have to give comma, that value I have to give. So suppose I gave here just I will, so it end with the dollar symbol. So now I will execute by pressing shift enter, we will get the result. Okay, what the result came? The result is that 1.3734. So suppose I want the precision little bit high, I can make it precision 6, 7 like that. Again I will make this 6, just I will shift enter, check it out, shift enter. See, the precision will be becoming more high. Again I will shift enter this. So see the precision value. So 6, 1, 2, 3, 4, 5, 6, 6 decimal result will be there. Suppose I don't want this repetition, I can make here a dollar symbol, so it will be not repeated, just will executed. See here, shift enter. So directly it will give the value. The value of given integral by the Weddles rule of the given problem is 1.37345. This is how the Weddles rule can be used to evaluate the function. Any function you can use between the limits 0 to 6. So how easily we can write this program to evaluate numerical integration of 1 divided by 1 plus x square from 0 to 6. I hope you understand this program. If you understand this, please like, share and comment about any doubt, and please subscribe this channel to get more videos on mathematical problems. Thank you very much for listening me. Thanks a lot. With